The front view of a line capital PQ is 80 mm long, measures 50 mm and is inclined to 40 to XY line at 50 degrees. One end of the line P is 20 mm above HP and 25 mm in front of VP. Draw the front view and top view of the line and find its inclination of the line with HP and VP. So now end P is 20 mm above HP, so NP is 20 mm above HP. When you look from the front view, the image will going to fall on the vertical plane, so you will going to get the distance which will going to be 20 mm above HP. So you mark that point as P dash. Then 25 mm in front of VP, so in front of VP is this distance. This distance can be seen only when you look from the top view. So that distance is projected onto the horizontal plane. You will going to get small p here. So this distance is in front of VP, which will be on HP. Now, the front view of a line capital PQ 80 mm long measures 50 mm and is inclined to XY line at 50 degrees. So we know the true length, but we don't know that inclination. Similarly, we know the front view and its inclination, which is 50 degrees. So first what we need to do is we need to draw the front view, because he has given the front view length and also the inclination is given. So with P dash as center, draw a line which is inclined at 50 degrees to XY line to a length of 50 mm. So then you will going to get this point as Q dash, because that is the front view. So you will going to get the locus of Q in the front view. So draw a dash dot line in vertical plane, because when you look from the front view, the image will going to be on the vertical plane. Now we know that the true length of the line is 80 mm. So with P dash as center, take a radius of 80 mm and cut an arc on the locus of Q in the front view, so that you will going to get this as Q1 dash. Since it is the true length, we mark that point as capital P and capital Q1. So now that means it is the distance, this is the true length which is parallel to VP. How do I know that it is parallel to VP? End P is in front of VP by 25 mm and end Q1 is also in front of VP by 25 mm. So that the line is parallel to VP. So how do I be able to find out that? Now when you are, since this line is in true length, so what we need, we have Q dash. So the distance between the end projectors in the front view and also in the top view will going to lie on the same line. So that means the Q point will going to lie on this end projector. But which one we need to consider? We need to consider the true length. We know that it is the true length in the vertical plane, so obviously that line has to be parallel to VP. So end P is in front of VP by 25 mm and end Q1 is also in front of VP by 25 mm. Then only that line will going to be parallel to VP. So you are getting this in space. But when it is projected onto the horizontal plane, you are going to get small q1 here, you are going to get small p here. So you are going to get PQ1 is the line which is parallel to VP, such that both P and small q1 will going to be in front of VP by 25 mm. So now we got the top view of this front view true line, so which is parallel to VP. But actually this Q1 will not be in front of VP by 25 mm, but instead, because due to the front view is on this projector, so naturally the top view of the point Q1 should also lie on this end projector. So how to do that? With P as center, take the radius of PQ1 and draw an arc such that it will going to cut in the top view the end projector, so that you will going to get small q here. So once you get this, now you know this is the locus of Q in the top view. So this will going to be marked as dash dot line. So when you are rotating like this, what happens? The vertical plane, the true length in the vertical plane which is parallel is rotated such that this Q point will going to lie, that is lie on this end projector only. So we are going to get this point small q. So when you are rotating it in space, obviously when you look from the top view, there will be an arc drawn from Q1 such that it will going to cuts the end projector line of Q, and Q dash will going to cut here. So this point will going to become small q, join peak and Q with a dark line because this is the front view. So now you got the locus. So similarly, but this is the line in space. When you are projecting from Q, you will going to get this point. When you are projecting from Q dash, you will going to get this point. Both are intersecting at this point. You mark this as capital Q and you mark this as capital P. So this is how we will be able to find out the top view and then the locus of Q in the top view. Now we need to find out. Now we need to find out the true length in the horizontal plane. So to find the true length in the horizontal plane, that means we need to find out this. So how can we do it? In this space, the line is PQ. With P as center, take a radius of PQ and draw an arc such that both P and Q2 will going to be above HP by 20 mm. So when you are rotating in space, what happens? When it is looks from the front view, the image will going to be rotated from Q dash to Q2 dash such that P dash Q2 dash is the line which is above HP by 20 mm. So now the line is parallel to HP. So when your line is parallel to HP, so we are projecting this down. So you are going to get the true length here. Since you are projecting this down, so you are going to project this also down. When you look from the front view, this is the projector what you have in the front view. But when you look from the top view, this line will be projected as if it is there from here. So this is the point which is going to cut the locus of Q here. So this will going to become Q2. So this is how, and then join P and Q2 with a little bit thicker than the projector line and identify the true inclination with respect to Vp and apparent inclination with respect to Vp. So this will going to be phi and beta. So this is how we can analyze this problem in 3 dimensions. But now we will going to solve this problem. First we will going to draw the xy line and mark xy and Vp HP. So distance of the end point P is 20 mm above HP and 25 mm in front of Vp. So above HP will always comes above xy line because the image is on vertical plane. So vertical plane is above xy line. From xy line you measure 20 mm and draw a horizontal line. Similarly 25 mm in front of Vp. In front of Vp is seen in HP. HP is below xy line. From xy line you measure the distance of 25 mm and draw a horizontal line which is parallel to xy. Then consider any point and draw a vertical projector so that it will going to cut both the lines, both in the front view and as well as in the top view at this point which is P dash and at this point which is P. Now, then we know the front view line is known, which is 50 mm, which is inclined at for 50 degrees to xy with P dash as center. Take by using the protractor, you measure an angle of 50 degree and draw an inclined line. So we know that 50 mm is the front view with P dash as center. Take the radius of 50 mm. By using the compass, you cut an arc on. By using the compass, you cut an arc on that 50 degree line. So you are going to get this point Q dash. Then join P dash Q dash with a dark line. So once you get the P dash Q dash with a dark line, so now we are going to get the locus line which is going to be a dash dot line. So then you write locus of Q here. Now, since we have the front view and also the true length, now you are going to take from you measure the true length of 80 mm by using the compass with P dash as center, cut an arc on this locus so that you are going to get this Q1 dash. Then since it is the true length of PQ, capital PQ, so you mark this as capital P and capital Q. Join P dash Q1 dash with little bit thicker than the projector line. So you will going to get this true length line. So this angle measured by this will going to be theta with respect to HP. That is the true inclination. Now we know that this is the top front view. So once you know the front view, so you can get the top view of the point capital Q will going to lie on this end projector. So how do I know that? Now since we know that, first we have to consider the true length in the vertical plane. Since it is the true length in the vertical plane, obviously in the top view that line should be parallel. So that means P is in front of Vp by 25 mm. Q1 should also be in front of Vp by 25 mm. That is what we have done here. P is also in front of VP and Q1 is also in front of VP by 25 mm. So draw a vertical projector from Q1 dash to the locus of P in the top view, so that both P and Q1 will going to be in front of VP by 25 mm. It is parallel to VP. But Q1 is not in front of VP by this distance, but instead the Q1 has to be on this end projector, so that it will going to get the top view, because this is the top view line, this is the top view of the front view line. This is the true length. So now once you get the small q, so you're going to get the small q, then join P and Q with a dark line, so this will going to be the top view. Once you get the top view, now we got the locus of Q in the top view. So now measure the angle with respect to beta. So now we got this. So we have this, we have got the top view now. Once you get the top view, now we are going to get the locus of Q in the top view. Now with P dash as center, take the radius of P dash Q dash, which will going to be 50 mm, and draw an arc by using the compass such that P dash will be above HP by 20 mm and Q2 dash is also above HP by 20 mm. That is what we have done here, PQ2, which is the line. When you look from the front view, P dash Q2 dash will going to be this line. Since you are rotating in space here, so when it is projected, you have rotated from this point to this, which will going to be on the vertical plane. Now, once you make this line parallel to HP, so we are going to get the true length in HP. So on Q2 dash, you draw a vertical projector so that it will going to cut the locus of Q in the top view. So mark this point as Q2. Since this line is parallel to HP, so you are getting the true length. You mark this as capital P and capital Q here. Then join P and Q2 with little bit thicker than the projector line, and then denote this as angle phi. That is the true inclination with respect to VP, which is phi, and the true inclination, apparent inclination with respect to VP, which is beta. So then by using the protractor, you measure the true inclination with respect to HP, which is theta, which will be 28.61 when you are doing it in the computer. When you are doing it in manual, it will be 29 degrees. Similarly, with P as center, you measure an angle by using the protractor. You measure the true inclination with respect to VP, which is phi, which will be 51.32 degrees when you are doing it in CAD. When you are doing it in manual, it will be 51 degree. Similarly, the true apparent inclination with respect to VP, which is beta, the beta measure when you are doing it in CAD, it will be 62.77. When you are doing it in manual, it will be 63 degree. So this is how we will be able to solve this particular problem. So we will going to analyze this also by step how we have considered. So here first we take draw XY line and mark PP and HP. So first we are going to take above HP, P dash, in front of VP, P. Then we know the front view line, which is 50 mm and 50 degrees. So from P dash you draw a line inclined at 50 degrees with 50 mm line. So once you get this, now you know the locus, you draw the locus. Then we know that the true length is known. So from here you measure 50 mm and cut an arc, and you mark this point as Q1 dash. And then since it is a true length line, you draw this line with little bit thicker than the projector line and mark this point as capital P and capital Q. So nothing is there in the top view except this line now. But we know that the front view of the top view of this point will going to be the top view of this point Q dash will going to lie on the end projector here. But we have only the true length here in the front view. So if this line has to be in true length in the front view, obviously that line has to be parallel to VP. So P is in front of VP by 25 mm, and the top view of this Q1 dash, which will going to become Q1, so which will going to be also in front of VP by 25 mm. But actually the Q1 is not here, because the top view has to lie on this end projector. With P as center, take the radius of PQ1 and draw an arc such that it will going to cut the end projector distance at this point. You will going to get this as small q. Once you get small q, then join P and Q with a dark line, which will going to be the top view, and measure the inclination with respect to VP, that is beta. So once you get the small q, then draw a dash dot line, which will going to be the locus of Q in the top view. So this is how we can be able to write the first step. So that is what we have done here. So first we have projected this point directly and then rotated. So instead in space you take P and Q1, then rotate it such that this q will going to be on this end projector here. So this point will going to become small q. So when you look from the top view, this line when it's projected, you will going to get this on this point, which is going to be q. Then join pq with a dark line. So then you are going to have the locus of q. So this is how we will be able to do analyze in the first step. Now in the second step, what happens is, so now we have the top view. Now we know the front view. So with P dash as center, take the radius of P dash Q dash, withdrawn, make it parallel to HP. Then project this to the top view and find the locus. Project this to the top view locus of Q and mark this point as Q2. Then join P and Q2. It's a little bit thicker than the projector line. So which is going to be the true inclination line. So measure the angle phi here. So this is what we have done with P as anchor. Take the radius of PQ and draw an arc such that both P and Q2 will be above HP by 20 mm. So when you look from the front view, this is going to be the line which is P dash Q dash, and this is how the direction of rotation when it is on the vertical plane. So then when you are projected onto the locus of Q, you are going to get the true length here. So in the space, this is going to be the true length in space. So this is how we can be able to analyze this problem and get the final solution. And we can also explaining this by step by step. But this is the combination of these two will going to be this problem. That is how we will be able to solve. The step by step is been given only to understand in the better manner, so that it will, which are the lines which are going to be drawn first, and how to find out the solution in a phased manner. This is how it is going to be explained.